Now, just like for Chapter 7, we had calculator functions that we used to, estimate population parameters. We're actually going to use very similar calculator functions to look at doing a hypothesis test. They're actually in the exact same menu too as your Chapter 7 problems. So if you're going to the calculator menu, hit the stat button and then go over to the test menu. We used down here, in Chapter 7, we use Z interval, T interval, and then one prop Z interval is a little bit further down. Well, you're actually going to use the almost exact same calculator function, except instead of interval, you're doing a hypothesis test. So you're not making a confidence interval, you're actually testing a claim about a population parameter. And that's one thing you definitely need to make sure you're kind of getting situated in your mind for your third exam is, which calculator functions do I use for certain problems. When it has hypothesis test or it has test a claim, okay, that's when you're going to be using, one of these three calculator functions right here. If it says test a claim or test a, hypothesis, something like that, that's where you're going to be using one of these. Whereas, if it said make a confidence interval or construct a estimate or whatever, estimate, that's when you're going to use something from Chapter 7, Z interval or something. Now, looking at these three right here, one thing to make a note here, and I will say, when you get to the homework, these are kind of separated out. This is section 8.2, and then these two calculator functions right here, they're both section 8.3, okay, on the homework. But, and then, of course, these are used for proportions up top. This is used for mean. One thing to note about these two with the mean, z-test, you use it when sigma, the population standard deviation, is known. So use it, or use when, we'll just say use when sigma is given. So when sigma is given, which is not going to be very common, that's probably going to be rare right there. You're not going to have that known very much. I mean, you'd have to collect, all the people in the population to figure out what that's going to be. So it's very unlikely you'll use that. I think there might be one problem where you might have to. Most of the time, though, you're going to be using t-test right here. So you want to use this one when sigma unknown. Okay. And then there are two methods that we'll be using to calculate a hypothesis test. Well, we won't be using both, but there's a test statistic method, which we're actually not going to cover that in a video in this class, but that's a method you could use. And then there's the p-value method, which is actually what we're going to show you today. How do you actually conduct a hypothesis test given the p-value? Okay. And I will say something about the p-value when we, just looking at it right here. You're going to first enter all your information into the calculator, because the p-value is a value you get straight from the calculator. So let's look at something here. Let me just enter some information here right quick. So what I'm going to do, I'm just going to show you here. I'm making up these values, but let's say we do a test on a mean where we don't have the population standard deviation. So I'm going to do t-test right here. And then I want to pick, I don't have all my data. We're just going to put in summary stats. So let's say the null hypothesis, we'll put it as 98.6, and then let's say we got 98.2 as our sample mean. My standard deviation, I'm just going to let that be 0.62, and then we'll say we gathered a sample of 40 people right there. Okay, and let's say that we want to, we'll just do not equal there for that. That's, by the way, this line right here, maybe I should point this out. This bottom line, when you do these different calculator functions, that's where you put your alternative hypothesis. The last line where it has not equal, less than, greater than, that's where you tell your calculator the alternative hypothesis. And then up here, the very top number, the mu0, you'll see a little 0 right there, that's actually your null hypothesis. So that'll be where you tell the calculator the null hypothesis. And then the very bottom line with the not equal, less than, greater than, that's where you tell the calculator the alternative hypothesis. Okay, and then you'll hit calculate. Now, after you hit calculate, you'll see like all these values on the next screen right here. Well, the p-value, in this case, is that 2.15 e-4 number. That is your p-value right there, okay, that you want. That's what you're going to get from the calculator. Now, how do we determine the conclusion for a hypothesis test after we've entered our data in the calculator and got a p-value? Well, you're going to do one of two things, okay? You're either going to reject the null hypothesis if the p-value is less than the significance level. So a lot of times they use significance levels like 0.5, 0.01, or 0.1 right there. Okay, so you're going to reject the null if the p-value is less than alpha or less than significance. Okay, and the way I think about this right here, there's a nice little mnemonic for this. But you know, if the p is low, the null must go. Now, what happens if the p-value is larger than the significance? Well, you're going to fail to reject. If the p is high, the null will fly. If you want the little mnemonic there. So if the p is high, let's look at an example here below. Say that we get a p-value of 2.61 e-8 from t-test for our sample. So we did something with our calculator, we put our information in t-test, and we got 2.61 e-8. If the significance level is 0.01, do we reject or fail to reject for this hypothesis test? Well, and this is what we call the initial conclusion right here. So our initial conclusion, will it be reject or fail to reject? Well, the p-value, okay, just writing it down here, it's 2.61 e-8, so that's 8 zeros. Put a decimal between the first two zeros that you drew, and then 261. So basically, you're just moving the decimal back. Like if you're moving it backwards, you're moving it back 8 places. Okay, that way. And then the significance level. That's what this alpha thing is. Significance. That is 0.01. Now, how do these two compare to each other? Well, the p-value is less than the significance. Okay, the p-value is less. And remember what you say. You know, the p is low, the null must go. So what will we end up saying? We're going to say we reject the null hypothesis. Okay. From there, you know, that's the initial conclusion. So that's how we get the kind of beginning. However, when we're saying our conclusion to our audience, you know, we don't want to just say like, you know, reject the null. Like, what did you actually figure out by saying something like that? Well, you're going to use some kind of technical wording that kind of addresses your claim that you're trying to test. So, you know, you might want to say, you know, there's sufficient evidence to support the gender choice drug being effective. Like something that addresses what the claim is you were trying to test the hypothesis of. Okay, right there. So what we're going to do is actually use the help of a cheat sheet, which it's actually in your notes on the next page. But you're actually going to use it to help guide you to the final wording that will, you know, be your solution for your homework or whatever. But yeah, you definitely want to make sure that you are doing this final wording, this final conclusion, and thinking through it. Like that's the hardest part too of the problems. You know, once you get the p-value from the calculator, it's nice. Then you got to think through like what exactly are the ramifications of what you just discovered by, you know, rejecting the null or whatever. You know, so that's what'll help you. The cheat sheet will help guide you to the wording. And one thing also is instead of saying, you know, we reject the null, why don't we accept the null, or like why don't we say accept? Well, some textbooks talk about we are not actually able to prove that this is always the case. We can't really prove the null hypothesis. Okay, because of that, you know, we have to say the terminology fail to reject. And you know, it's because you could have a rare event happen. You know, just because this ended up happening for our sample, we don't know 100% that it was not a rare event. So we can't really say this is how this always operates. Okay, like in the example before with the babies, where we had 95, babies born, girl babies born in 100, that could have just been by chance, because it can actually happen by chance. It's just very, very unlikely, but we don't know what really went on there. So we can't really prove the null hypothesis 100%. So that's when we say fail to reject. And if you want to think about, like, why do we do this, or what's the point, or whatever, it's kind of like the wording that you think about with the judge when they're, judging you in court. Like, do they say, innocent? Like, do they declare people innocent? Well, no, they can't do that. They actually just say not guilty. And it's very similar to that. Like, they can't really, know if the person committed the crime or not. It's just the evidence that was put before them was not enough to, convict them or whatever. So it's the same kind of idea there. Now, on ours right here, we're going to use the flowchart to show you how to use it and look at an original claim, which this one says the percentage of blue M&Ms is greater than 5%. Right there. So that's like some claim in the problem that they'll want us to test. Okay. And of course, then you would start setting up your null and alternative hypothesis and then putting stuff in your calculator based on your sample. We don't have all that in this problem, but we don't need it to do what we're going to do. So that'll come later in 8.2, 8.3. But then it says our initial conclusion ends up being fail to reject the null hypothesis. So we actually have an initial conclusion from whatever scenario they have here. Well, how do we get the final conclusions wording? That's what we want to focus on. And this is what I'm going to say is use the flowchart on the next page to help guide you to that solution. So looking down here, we see, of course, start here. Does the original claim contain the condition of equality? Okay. Well, if you look back up here at the original claim, it says percentage of blue M&Ms is greater than 5%. So the original claim actually does not have equal. So we're going to follow the no path. It just has greater than symbol. It don't have, equal. Now, do we reject the null hypothesis? And that is your initial conclusion, that you will get when you compare the p-value to the significance. Okay, right there. So the initial conclusion, well, they give us the initial conclusion is fail to reject the null hypothesis. So we want to follow that pathing right there. So we fail to reject the null, and this is the wording right here. There is not sufficient sample evidence to support the claim that, and then whatever claim you were trying to originally test. In our case, the percentage of blue M&Ms is greater than 5%. Okay, so that's what we're going to have right there. Okay, so our final conclusion will be this right here. Okay, there is, you can say insufficient. Sometimes the homework will have that actually, but there is insufficient or there is not sufficient sample evidence to support the claim. That, and then you just write down their claim that was in the problem that you're trying to test. So in this case, that the percent of blue M&Ms is greater than 5%. And that right there is how you conduct a hypothesis test, or that'll be how you get to the final conclusion of a hypothesis test. Now in the next sections, we'll actually be doing some hypothesis tests and putting all of these components together in one big problem.